Welcome everyone. We'll start the session. Today we'll be discussing cyber resiliency and AI and data for your approach. With us, we have Tao Tutsi from IBM. Tao's got an industrial engineering degree and has joined IBM in 2019. He joined the group as a storage specialist and is now the senior channel lead for storage in Canada. We also have Frank Lee, which is a director and a distinguished engineer with the IBM Storage Group. Frank has got a PhD in storage specialist, but basically he's got a PhD in molecular structure and biology. And he will be discussing AI and data, particularly with AI, with our group. So we'll start with Tao and myself, Jean Besnet. I'm a solution designer with NOVIPRO. 34-year experience with IBM, joined NOVIPRO about a year ago, designing solution with infrastructure, AI, data, and numerous things. So without further ado, Tao, take it away.
Thank you so much. Jean. The reality is NOVIPRO is one of the partners that are actually dear to my heart. And Jean Bazinet was one of my mentors when I had joined IBM. So, when he told me about having to talk about cyber resilience, I could not say no for that reason. So first of all, thank you for your mentorship. I am who I am today, thanks to you. Thank you very much. And, today, I've a few years ago, the conversation that we'd had around storage had to do with capacity add, had to do with storing, but only that. Now, more and more, we're steering these conversations to include some level of cybersecurity talk, and we're including cyber resilience on top of that, so we can deliver a very good experience end to end to deliver a storage that not only is secure but also resilience in terms of recovery. So we'll first the next slide, just for me to start giving you some background about why cyber resilience is really important, but also why cyber resilience is at the storage level. So first of all, the average annual cost for a company that averages about 25,000 employees, the average annual cost for a cyber breach is about $5.2 million. This is a timeline since of 2021 of the number of ransomwares or all the ransomware incidents and cyber attacks that had happened across the world. So we can start with the city of Angers, and then we talk about the computer giant Acer, also the engineering giant Ver Group, and the wind turbine giant Vestas. And these are major corporations, major places where this ended up happening. The problem is that the trend that we're seeing is that 83% of the victims actually end up paying. And on top of that, you have an average of 23 days for you to be able to recover and recover effectively. Now, the logical question you might ask is, well, you know what? We have insurance, and that's all fine and dandy. But the reality is, even insurance companies are starting to put that in the clauses, in the contractual obligation to have some level of resilience, to have some level of security for them to be able to insure you. And the policies generally include that. So this is also a conversation that includes the insurance folks. If you want them to protect your data, insure your data. Next slide, please. So next slide again. So we want to start where does this exist? Where does this data resilience start? Well, instead of having to do this at the application layer, what IBM decided to do is that we can go and secure the core of it all. And we've been doing this for years. This isn't a new trend. We're not following some sort of trend. We have set the trend ever since we started, doing storage. And so we have had multiple ways of doing this. And one of them is failure protection. So having high availability really helped us protect against the failure, because if one of those storage arrays go down, at least you have access to another one. So it raises your availability of 99.999% to 100% uptime. We also have strategies that are centered around disaster protection, and that is an enterprise disaster recovery that you can deploy both on-prem and or the cloud, or have a mix of the two. We also do encryption. That's also a good strategy. But encrypting that shouldn't have to impact the performance of the storage array, which is why we have ways to have some level of, or to have a broad encryption, but absolutely no impact on the performance. And finally, to protect against the cyber attacks, well, folks, the way to do this is immutable copies. And you have to have some level of air gap, whether that is a logical air gap or a physical air gap, which is why we're still talking about tape, for example. Tape is still relevant. A lot of people think it's dead, but it isn't. It's because it guarantees maximal effectiveness in terms of protecting the data, because it's completely segregated from and we learned that lesson from tape. So we wanted to do this on our production arrays, but we do it in a logical way. So the idea is that it's not really tied to any host. So even if you get attacked, nothing gets to that particular part of the array. Next slide, please.
Now, Tao, because most people have a foot on-prem and they have a foot in the cloud. Now, with those two types of things, is there a way to reconcile those two types of data within the?
Absolutely. Look, we made an acquisition in 2019 that actually made some waves of around 30 some billion dollars of Red Hat, centered around, and that all was to support our strategy of hybrid multi-cloud. So no solution makes sense to just stay on-prem or stay on the cloud. We need to be able to seamlessly navigate the two. And we have that even for storage. So for example, Spectrum Storage Virtualized, I'm still using the old acronyms, but Storage Virtualized, for example, is the way to consolidate your storage across the board in your data center. The idea being that it doesn't have to be exclusive to the data center or on-prem. You can also control the data that you have on the cloud. We have software that does just that.
Okay, and it works with numerous cloud, right? It works with numerous cloud, like
right.
Azure. Okay, so basically people that have numerous cloud can actually control their data centrally?
Right. So that's the idea. The idea is that we do this across the board. We work with AWS, for example. We work with the IBM Cloud folks. We work with Azure. We work with Google Cloud. We work with all of them, the major providers, and even some of the smaller providers. We do this just to ensure that there's a seamless, data motion and data movement between what you have on-prem versus what's on the cloud, and amongst the clouds that you also have, because no one just has one single cloud or two clouds. Sometimes people have up to 5 clouds, and you need to be able to navigate it effectively.
Okay, thanks.
Yeah, good question. Good question though. That's really interesting. So here's the reality. So we're talking about disaster recovery, and that is a CIO problem. And disaster recovery, at the end of the day, is a regional endeavor. So if the temperatures go low fast, then you may have some pipe that freezes and ends up screwing up the electricity, for example, or if you have some sort of storm that ends up screwing up the services or your internet provider. Sure, but these things are actually regional. So if you want to be able to recover from that disaster, you know exactly when to get back from that. And the probability is fairly low. The last thing this happened in Quebec was, I think, in 1999, where I think the electricity, there was some electricity break, something along those lines. Not really all too familiar with that story, but I think it's the verglas, if I'm not mistaken. And that's, when you had electricity across the board being cut off. So if that happened again, that would constitute a disaster recovery for which you need to have a strategy. But cyber recovery is actually entirely different in that regard, in that it is a global, it is an epidemic. If you get targeted, it's not just one part of it that gets targeted. It's global. Whatever operations you have globally will be impacted. And also the recovery point is not known because you don't know when you got attacked. And so, but all of this makes that cyber recovery important, on top of the fact that the probability is fairly high. So this is the idea of having a data resilient solution, because you need to be able to do cyber recovery concurrent with a high level of disaster recovery strategy. And that's what we try to do with IBM storage solutions. And when I say storage, I just don't mean the hardware. I also mean the software defined piece. Next slide, please. So what are we trying to achieve with storage, with IBM storage in terms of security and protection? Well, first of all, we use the NIST framework, and this is a framework that is fairly international, fairly global and universal in the way that it's set. And so we have to be able to make the distinction between the data security versus data protection. Data protection is your ability to identify, to protect, to detect, and to respond to your threats. And that is a cybersecurity endeavor. We have a cybersecurity business, folks that can actually lead you and help you lead your way through a cyber secure environment. But when it comes to recovery, and we believe that it's not really a matter of if, it's a matter of when, you need a recovery strategy that that helps you fulfill not only the NIST framework, but also allows you to continue your operations without really having to sacrifice anything. And data protection and data security, when you put them together, that's when you get your data resilience. And that is, again, like I said, it's a chief data officer conversation, chief information officer conversation. These are all about managing the risk, except we're managing it from the storage array. Next slide, please. So how do you get to that sort of data resilience haven? Well, we have phases, and we have a roadmap that we help you craft to get to that level. And first of all, without really foundational security and data protection, it's really hard to talk about anything else, because you need to be able to predict and prevent. You need a response to event management. We have products, for example, we have software solutions, QRadar, XDR, Guardium, that actually help you at the prevention level. But one step forward, you need a level of immutability, something that is completely segregated from the network, such that if something were to happen, then you're still there and you're still able to recover. And discovery is when you, in case you've been compromised, what you effectively do is that you use some mechanisms to be able to parse that data and see where the malware, how did the whole thing happen, find out within the data pattern and try to grab some insights out of it. And so this leads to the next point where, once you've discovered, well, what do you do now? Well, you recover. And the recovery basically is, instead of having to go 23 days without really having the minimum viable company, or having to shut down operations, being on the bench of inaction for months, well, you get to do this, and then you get to do this recovery from within minutes or within hours. And of course, the ultimate haven, which is the automation. So the basic idea in the automation is that you have all these sorts of solutions, all these sorts of things cooperating, orchestrating with one another, and doing the whole thing independent of an agent that is monitoring them. And that is the whole principle of automation. Next slide, please. The reason I wanted to take a step back and then give you just an example of how we do this. So typically, a backup is what you would go for in the event of a cyber attack. So what we decided to do is that you don't really need to go back all the way back to that to your backup. We can have some backup. Well, it's not exactly a backup. We take snapshots on the production arrays, and we keep them on the same production array. So it really minimizes the time to recovery. So let's say you take snapshots. You take copies. Every 3 hours, 6 a.m., 9 a.m., 12 a.m., and 3 and at 6. And then you realize that there's a corruption. So within that storage array, there is a part that is air gapped. The only thing that and these are copies that no one can actually delete. Not even your own administrators can actually delete. And then you go and then find out what happened. So I found out that there's a corruption. And then I go back to those safeguarded copies. And then I take the copy 1, and I realize it's actually infected. Maybe the infected happened before 9. And then I go back to the other one at 12, and then I go back to the other one at 3, and so on and so forth, until I realize that I have a copy that is fully operational. All I need to do, put that back in a recovery volume, and then put it back in your production volume, and then you're up and running. Backup may take a lot longer to do, as opposed to doing this on the production storage array.
Now, is there a mean for that where, because hackers sometimes get in your systems a little bit of time before you actually did these things, how can you actually ensure, do you have a mechanism to investigate if the copy that you've got stored and that you want to restore in your volumes or on servers, if they're entire, to make sure that they're actually clean copies?
Right. So here's the thing. The reality is you can parse those copies, and this goes to the previous slide, for example, that I talked about, that level of discovery that you need to have over your data. So Cyber Vault, for example, is a methodology that we've developed here at IBM that helps you when you take, let's say, these snapshots, that in the event something bad happens, you can go back to these snapshots and then investigate them. There are mechanisms by which you can investigate. So you bring up this copy first, for example, and then you run it again on your production server, and you see on your production, and then you see, is this a bad copy or a good copy? And then you do it over and over again. There are ways that expedite all of these things, but there are ways. Cyber Vault methodology helps you with this, and it develops a huge framework for you to be able to take those snapshots, investigate those snapshots, and also restore them back to production as quickly as possible.
Okay.
So the idea is just so far, we'll let's go a couple of slides forward. The idea is that so far what I've spoken about had a lot more to do with our hardware and the software that comes with the production hardware. But what we have recently realized is that having multiple solutions to the same problem, believe me, is not going to get us anywhere. So what we decided to do is we launched a new product, and this was generally announced back on May 26th. It is the ultimate idea for data resilience. And what we have to understand is that across those phases that I've described earlier, you have your cybersecurity part, your data protection, your data classification. But more importantly, what we did was each client, each company has specific goals in mind. It doesn't make sense to just, let's say, give or solution a backup solution, a backup solution to company A and do the same thing for company B, or partner A for partner B. We have to take this approach holistically. So what we did is we launched Storage Defender. Storage Defender is an end-to-end solution that is capable of providing data resilience to clients, whether that is on primary storage, secondary storage, all the way to the bottom at the tape. And I don't know of any other company that has a comprehensive solution the way we do it, but Defender came in response to this, came in response to this sort of decentralized operation. So you consolidate the whole thing and you have access to one platform that can view your inventory, can also proactively help you detect corruptions, can also help you with the recovery. So for example, you notice there is that in phase 4, you have your minimum viable company. What does that mean? Minimum viable company is that you're probably about 30 or 35% of your data that's effectively, it has to be stored on array. So in the event of a cyber attack, you get to recover it quickly. So you start on the basic operations that you have, and then later reach out to your backup and then bring back all the full company. And you can do this, with Storage Defender. You can do this with Storage Defender by having both that care of your primary array, but also of your secondary arrays too, and have a high level of orchestration between your source or your event management, so on and so forth. And this is something that we just announced back in May 26th. I'm more than happy to take calls about Storage Defender specifically, because it's our new passion now, and it's end-to-end. So, we're not going to be talking about multiple things at the same time. We're just going to talk about one. Next slide, please. So yes. So I think my time has come close to be done. I hope I'm not really over time, but I just wanted to leave you with just a few ideas, about what the future means for data resilience. Data resilience is not a blanket word that you can throw on anything. It isn't. It just simply isn't. Data resilience means that you have to have a level of holistic visibility. You have to have a holistic approach to it. Each company, each side is solutioned differently from one another. A company that does manufacturing cannot be, compared to a bank, cannot be compared to the healthcare sector, to a federal government, to a provincial government, so on and so forth. And you also need early threat detection. It's better to be safe than sorry, but if you are sorry, you better mean that you are sorry. And you also have to have a coordinated response, and coordinated response across the board between the cybersecurity and your cyber resilience. And of course, the most ultimate thing is rapid recovery. Rapid recovery is really important because that is what guarantees the revenue, your operations that really yield your revenue and ultimately your profit. So business resilience is tied to data resilience, especially now, especially if you're a company that is data driven. all of it rests upon the data.
Well, that's excellent, Tao. Thank you for your time, and I want to remember everyone that we do have a Q&A section where you could put your question, which we will answer at the end. And at the end of our presentation, there will be contacts, myself, by the way. So should any topic would you like to discuss, or any topic at all on infrastructure, data, and etc., just feel free to contact us at NOVIPRO, and we'll get you in touch with the expert like Tao. On this, we will be switching topics to go to Highway for Data and Home for AI with Frank Lee. You can take it away, Frank.
Yeah, thank you, Jean, and also Kenza for inviting me. NOVIPRO is a very, very important partner for us. As a matter of fact, I'm sending one of my technical leaders, Josh Bloomer, to you next week for installing the solution I'll be sharing with you today. One of the key here I want to hopefully you can take home is as you're planning for your AI platform or your data platform, just like security, right? This is it's critical to have a plan, architecture, and a very critical partner, right? Like NOVIPRO to help you on this journey. And this is no different from all the other generation of technology we've seen in the past. But right now, of course, you probably see and hear and play with ChatGPT, and you know that AI is transforming the industry. You're either transforming it or you're being transformed, right? Probably most importantly, I actually gave a talk at MIT AI Lab about a month ago. I think everybody in the room knows what now generative AI is, thanks to ChatGPT, but also its potential impact on their bottom line. Some of them even now saying, while there's a constraint on their budgets, now they have a budget actually on Gen AI. Right? So this is actually a very important topic for you. But I would expand it a little bit in terms of not just looking at AI itself, but also the infrastructure and the security around this, right? And these actually are three imperative that is leading the leaderboard for many of our clients and partners. How to modernize the infrastructure, how to leverage AI for digital transformation, not just to develop a model, but actually infuse the AI in a trustworthy way into the business workflow. And also on top of that, you just hear from Tao, how to provide cybersecurity and governance, right? A lot of the model, garbage in, garbage out. How do you govern your data to ensure privacy, to ensure that your data is governed? And also protect your data, because one thing that is unique about AI, which I'll share later, is the amount of data that you will need and involve, right, to build a model and to fine-tune the model, for example. So how can IBM and NOVIPRO help, right? So at the bottom here, you can see we have years of experience, expertise, and capability around hardware and software, right? So when I talk about IBM storage, it's just like Tao just mentioned, right? It's not just boxes, tape and disk, but also now software capability, solutions that expand the full stack, right? So I just call that enterprise or information architecture, IA, right? So think about AI without IA. I can show you it will be a mistake, right? So you can avoid that mistake by starting on the right stage with the right partner like NOVIPRO. The other thing I want to mention here is, think about your own journey, right? Which is probably the most challenging problem you're dealing with. Number one, to get started, or just how to work with your existing infrastructure, right? Do you see challenges? So feel free to post a question here. I do see the fourth dimension, which I mentioned under the number one here, is number one, scalability, right? AI is pushing the envelope because AI is now requiring a lot of computing power. If you know there's a global shortage of GPU, that this is one of the reasons. Number two is reduce cost, right? Now, because the need for more data and infrastructure to develop, deploy, and maintain these AI workloads, and we see a tremendous potential hockey stick effect, if you will, that the cost will go up. So how do we control that? Number three is how do you develop and deploy a lot of these AI infrastructure, which are considered cloud native, right? Using, if you look at the diagram on the left, right, onto any cloud or on premise, And lastly, to make it resilient, right? So the platform can tolerate a operational business disaster, if you will, or cyber attack. So feel free to put a question in the chat, and we can.
I do have one, Frank.
Okay. Yep.
You know, a lot of people, like, you know, we hear about ChatGPT, we hear about all those chatbot and etc. ChatGPT, you could actually ask it to code for you, and they actually promote code and they generate code. Now, most, I think, still enterprise and probably some of our customers on the chat right now may not have started their journey. So basically, would that be part of the building blocks, or, you know, how to build an AI platform so that, you know, they could start working with it?
Yeah, absolutely. So that's a great question, by the way. So you do have the mind share, right, behind you. People wants to use AI now. They realize finally that AI is not just for, you know, a small task, answer one question, but now you can train a enterprise, a large model. We call them foundational model, right? That's trained on large with unsupervised data, and then use that model as a base, and then use that to fine tune for a specific task, right? Like in the case of ChatGPT, you know, Q&A, right? Question answering or translation. And the next generation would do, you know, image recognition, you know, video translation, and so on, right? So we can think about that as a base that you can leverage, right? But you can also use that as a building block. So in other words, in the journey you're about to start, you can start small by, for example, look at the specific use case or task, right? That tailor to your business. So when I met with clients at MIT, for example, one of them is in the construction business, right? They're looking at how they can improve the condition of which they can, you know, develop concrete, right? With the weather, the temperature, so you can have an AI model that can help them actually improve business and the business process, right? So keep that in mind as you start this journey. Is, you know, ChatGPT is great for one task, but in our case or your case here, right? How do you develop a platform, take advantage of the data you already have, right? And develop an AI model or platform that is specific, tailored to your task.
Exactly. So that would be actually specific to requests made by each business within our customer's structure, right? So something
exactly
that's adapted to them.
Yeah. Okay. Yeah. And then, you know, here what I'm presenting is really about how you, right, customers and partners can leveraging this, let's call this a stack, right, in 3 different color. The red color is about having a platform to deploy the AI applications, right? The blue layer, we call them global data platform, is how you can use this to help you manage data. So think about, you know, compute, right, and data. Right? And then, of course, resiliency, end-to-end resiliency down to the core is also part of this, because Tao already presented it, so I'm not going to go into the green layer, but mainly focusing on the red and blue, and just show you what they are and why do you need them, and then give you a couple of use case, right, in terms of when you're planning this, right, you can start in any one of these layers, but if you want to do AI, it'll be really awesome and valuable, and eventually when you have a real use case, right, you can develop a vertical software stack or IA, right, to drive your use case. So, and then you can see on the left, you can deploy this based on this architecture or building block to an infrastructure that is to your preference, or being, in some cases, we're seeing, you know, different constraints, whether it's governance, locality of data, privacy requirements, right? You might have constraints in terms of where you can deploy the AI platform. And then this architecture can really help you decide, design, and deploy a platform meeting these different requirements and compliance and security as well. So let's look at the hybrid cloud, the red piece first. So think about this as a layer to deploy your applications. In this case, all the tool you need to develop, train, deploy, and run applications, which includes AI models and also analytics, traditional analytics, right? So this is a platform that is also, let's call this consistent with hybrid cloud strategy architecture, right? So the model, which I think mentioned earlier is if you have something you want to develop on-prem, then you want to run it in the cloud, right? You need a layer that can help you abstract out the underlying infrastructure. So this layer is a hybrid cloud platform. And in specific, it's based on a containerized platform that allows you to deploy this pretty much everywhere, right? AWS, Azure, Google, on-prem at VMware, even onto mainframe, IBM mainframe, Power, and even bare metal, right? Commodity servers, right? So this is a layer you need to have that consistency, whether the application is AI model, workbench, right? That you would use to train the model, an application hub, right? You can define, design, and deploy policy to help you manage applications, right? So this layer is what you need to build a home for AI. And a lot of this model, by the way, runs in containers now. So you do need this container platform to help you manage it. So what they actually look like from a product perspective. So there's two flavors of this based on IBM Storage Fusion. There's a Fusion software where you can deploy this everywhere and anywhere where you run your platform or build your AI platform. And then there is a appliance version on the right. You can see there's a rack, right? It comes fully installed, wired up, including the hardware, software, and the server. And within a day or two, you have a fully ready to go platform to run and deploy your AI platform. So we call this a Fusion HCI system. And this is what it looks like inside the box. You have lots of servers, and you can expand this from one rack to multiple racks. You can add servers, and take note that we actually have GPU here that you can run, deploy an AI model, which require GPU for inferencing and training. So the bottom line here is this makes your AI platform deployment really, really, really easy. So let's look at the blue layer, the data highway, right? Every generation of ChatGPT, when you train them, requires 10x more data, right? This is a software capability, but also it speaks to the volume of data that we can handle, and we will be requiring, right? So to do that, you can think about the data that you already have, right? The data that speaks to your business requirements, needs, the data you collected from engagement with your clients, with your partners. All the data that you're now be looking at is probably not going to be in one place, right? So they're going to be probably in a file store somewhere, in object store, in a tape library. We see a lot of that in data lake, which I'll talk about a new technology called Lakehouse. And lots of these data are unstructured, like file, right? Like videos, images, logs, right? And lots of data are in a table or database or data warehouse, right? So how do you bring all this together into a consistent, what we call global namespace, where your AI application or platform can access, right? To enable this collaboration and virtualization to a degree, right? Because you don't want every application to deal with the underlying storage and data management platform individually, right? You want to have this virtualized global accessibility to data while providing resiliency on the right. So these are the four services, right? Accessing data, being able to move data and virtualizing them, and manage the life cycle of data wherever they are, and providing resiliency. This is what IBM Global Data Platform provides. So now you can think of this not just a piece of software or a hardware anymore, right? This just like the resiliency that Todd mentioned earlier, right? It's a layered service that give you and deliver a capability for the full life cycle of data. In this particular case, for AI, right? So let me bring this together. What does it actually look like, right? We have these layers, and we are addressing these fundamental challenge of data, right? A lot of data. You can see the growth. It's a straight line up. Sometimes I see hockey stick, right? I mentioned earlier before the call to Kenzar and a friend here from NOVIPRO that the very first human genome was sequenced using $1.5 billion, 15 countries, a decade. But now, and that generates about a terabyte of data, right? 15 years. But now we can do that in a matter of a day with less than $1,000, right? So the genomics that we're using today for diagnostics, cancer preventions, are generating so much data. The only other industry can rival this is autonomous driving, where they're collecting data, 10 terabytes a vehicle with a fleet of 100, so 1 petabyte a day, right? And all these data are now being used to build AI model. So scalability of being able to deal with a large volume of data, while data is also being spread all over the place, right? And then finally, different formats. I mentioned videos, images, and then governance and quality control of the data, right? Garbage in, garbage out. You don't want to garbage in to your preciously built model, right? You want them to be governed. You want them to be fair. You want them to compliant with regulation and privacy, right? So this is a graphical view of this, right? You have data everywhere. The consumer and the provider here is almost mixed, right? Some of the resource on the left can also become a consumer, right? You also have end user UI on the right, and then you have data lake in the middle, right? How do you connect all of them into a platform? And then this is another view of this very similarly, but for structured data, right? So on the lower left quad, these are traditional database, data warehouse that stored lots of data. And we have the early experiment of that moving to data lake because the data is growing so fast, right? So, a lot of deployment around leveraging Hadoop and data lake to store large amounts of data, structured, unstructured. And up to the top, you can see there's technology also now runs in the cloud for cloud data warehouse. But then these two doesn't really sort of scale and interoperate, right? So there's a new technology called Lakehouse that brings this all together, the data warehouse and the data lake, right? While providing a highly scalable runtime query engine called Presto and Spark, right? So IBM is actually releasing a new technology called watsonx.data that maps to this technology and ecosystem. It is the same technology that we will be using for global data platform for AI. Okay, so to sort of put this all together into a stack, I call this IA for AI. So think about if you have an AI project, right, that you want to build this capability, right? The information architecture we're proposing here, which involving the hybrid cloud platform to deploy the workloads, right? The blue layer, which help you to bring the data together. In some cases, you don't have to move them. You want to keep the data where they are, right? That's also applying to unstructured data and also the structured data, which is the lakehouse, right? So now with this and then plus the resiliency, I think you have the enterprise stack, right, for AI. Okay. Now, and on the left, question? Okay.
Yeah, well, that's, AI and the training of the model, right, is very demanding data-wise, right? It takes tons of data in order to do it. Now, when the customers got their data spread over numerous, cloud, similar to what we discussed with Tao, basically can actually that thing tie it in all the data for that so that the customer can exploit? Is there any means to facilitate the transfer of data and then basically build your model with the data that's spread, among numerous locations?
Yeah, it's a very timely question. Actually, working with a client this morning, that they have a on-prem deployment of the AI platform, right? The red piece and the blue piece and the green piece, as a matter of fact. But they also have data in Azure, right, on the upper left, right? You see, but the AI model needs to access the data from both sides, right? So in this case, you can think about multiple options, right? You can build a AI platform on-prem and you can build another one in Azure, or even using the Azure stack. But how about you can build a single platform, either on-premise or in the cloud, right? The red piece with a workbench, right, for the data scientist. Yet you can have access to data from both sides, right? So the global data platform, the blue piece, actually help make that happen, right? So think about that the notion of a data highway is now the data can be made available. Sometimes they have to travel, right? When we do travel with the data or make the data travel, we actually don't make a copy, right? We create a cache. So think about the cache is the experience you have with like a box folder, right? And maintaining the namespace. So in that case, I can bring the data when needed on demand securely, right, from the source to the platform, and then make that data available to the GPU for training, for example, right? In the question you asked, my AI is going to run and train using these very expensive GPU, whether it's in cloud or on premise, you're going to buy, right? If you happen to be able to get one. So you don't want to keep your GPU waiting for data, right? So what the global data platform is, think about a very high performance highway that can move the data on demand, like a fast delivery, right? And then bring it to the door, the doorstep of the GPU, feed right into the GPU. By the way, IBM has the world's fastest data machine for GPU. I have a slide on that, right? To feed this GPU, right? No matter where the data are. So bring the data closer and then feed them into the AI training platform.
Okay, so we get rid of the latency. So we can basically get rid of the latency between the outside location and location when you want to train your model and you want your GPU to run because they're very expensive piece of hardware.
Absolutely, yeah.
Speed.
Yeah.
Okay, so
yeah, there's a latency, right? Feeding to the GPU, there's also latency to move the data from one location to the other. And, the third thing I would add is reducing the egress cost. So let's say you want to build this in cloud, right? You don't want your AI platform, the red piece, to constantly accessing the data in the object storage, because that's where the cost will add up really, really quickly. Because every time you ping the object store, you incur an API call and a ring to the register bell, right? And adding a penny or a dollar and eventually a lot of money to a monthly bill. But with the blue piece, we can cache the data out of object store and make it available to the GPU only once. Then you minimize your egress cost. That's a tremendous cost saving, by the way. We have lots of use case and TCO analysis on that. Be happy to share with you.
Yeah, that's something our customer may actually be interested in looking at because egress cost is where a lot of the cloud provider makes a lot of money, right? When you actually get the data out their location.
Exactly. Now, a year ago, I don't get that question a lot, right? Because people are doing data science and machine learning. Once in a while, they do a deep learning involving some more data. But now, Gen AI, ChatGPT, this is completely different, right? Everybody is going back and finding every piece of data they can to either fine tune or train the model. So the volume will go up a lot, more than any one of us can imagine, right? And you should be ready for that. Okay, so let me go through 4 quick examples of how we can do this together with NOVIPRO, IBM, and your own team, right? So the first scenario is, how do you start, right? This is probably the most common question I got. Like, I heard about this, I went to a webinar, went to a seminar, but how can I start, right? And thanks to the cloud platform, this can be really, really quick and a quick win for you to build and show MVP, right? So one example here, I don't know if you remember these icons here. So I have 2 icons right here in the red piece. One is let's call this a workbench. The other is a catalog, right? The workbench allow you to build, collaborate as a team of data scientists or engineer, right? And the catalog allow you to govern, find, and even in some cases move the data if needed, right? 2 essential service, if you will, for the AI platform, right? And you can do that and then build that really, really quickly, right? If you have a platform on premise, we can help build that demo for you, or we can go to your cloud account and build something similar. NOVIPRO is going to get a Fusion HCI, that box I showed you early, right? So we can work with you to do a code design at NOVIPRO, right? To build the catalog. Now, what the catalog look like is you have lots of data and you ask a question, where's my data, right? Because I'm in healthcare in this background, so how can I find my medical imaging based on the patient information? Find me all the patient medical images that fits a specific diagnosis and of an age group, right? But while do that, you need to be HIPAA compliant, so you don't want to have data that reveal the patient identity, right? So I actually have a GitHub. It's a public GitHub that I built a demo you can use, right, to build this catalog, and then how to access a catalog using, for example, free tool like dbeaver, right, or Eclipse, all the way up to a lakehouse. On the right, you can also, in the same context, you can quickly deploy a workbench. So what is a workbench, right? So think about a data scientist using Jupyter Notebook on the laptop, right? And not being able to share, collaborate, and protect the data. But now with a workbench running in Fusion on top of OpenShift, you can see I can create different projects. I can create unlimited number of Jupyter Notebook or workbench, right? And then run AI experiment like shown, in this screen capture in a Jupyter Notebook, and I do an AI inference using a model to detect or diagnose cancer from a pathology slide, right? So very powerful MVP you can build that usually take months or, half a year to do, right? From server hardware all the way to software. Now we can do this in a matter of days. So that could be a quick start for you to say, we heard about all this excitement around AI. How can I get started, right? How can I show to my user, my customer, the benefits of AI, right? By bringing the data together and by bringing the workbench and make it available to you quickly. The second one is think big, right? And the workbench and the catalog allow you to show this to the user, and the business value, right? How can I get started? How can I use AI? What is the value? But let's keep also this insight, which is the problem we can actually take on, right? So here I use a very good example of one of the largest cancer center in the US, as a matter of fact, second largest in the US, that is deploying the global data platform, which is IBM product is called Storage Scale, with the AI platform for NVIDIA, right? The A100. And they're using the platform to do, right, building an AI model to do cancer diagnosis and preventions, right? Now you can see here the server is, right, compute server. They have the NVIDIA in the gold color right here, right? So the global data platform can actually tie them together and also providing a resiliency to a degree, right, with even 40 miles apart to different data center. But probably most interesting for me is that box right here called ESS 3500. It is the world's fastest data machine, right, to feed the GPUs at 126 gigabytes per second. It's a world record, right? In a 2U box, we can feed the NVIDIA box, which is also very expensive. Our 3500 is much, much more affordable, right? But you need this to couple the two together to form the killer combo of AI, right? Data machine for AI. We also have white paper. So once we have the follow-up, please request, right, the deck, and I have the link to the two white paper we co-published with NVIDIA. So let's put it this way. If your customer or yourself, right, toward the end of the year, say, I have a starting point. I know how to build MVP. I can work with NOVIPRO to show me MVP, but I do have a budget, right? And if you happen to be able to put your hands on a NVIDIA A100, like a super pod, we call them, right? And then, get an ESS 3500, think and scale big. We can get there, right? The world's fastest supercomputer even use this same technology, right? So we can start very small, but you can grow and scale very, very large, right? Because, and by the way, you need that, right, to build your AI model for training. How about moving data, right, if we need to? So here I'm giving you an example of a real customer on the left. That's University of Queensland in Australia. And that's not a subway map, by the way. That's actually, every one of these line is a line of data caching using global data platform, right? So the source of data, the provider of data, where the data is also going to be consumed, is actually going to be different, right? You can imagine you are collecting a lot of data in different places, different locality. If you're retail, you can have different shops, right? If you're autonomous driving, a research company, like one of our reference called ZF in Germany, they are collecting data, with, vehicles in the field, right? And data is uploaded. So all these lines representing ability to move and cache data wherever the data is needed, right? Now on the right, we're enhancing this capability by emerging the global data platform with a catalog. In other words, up until today, we still move data in a very big chunk, right? A file, file system, or we call them file set. Think of them as millions of files. But going forward, which actually we're doing early pilots. So if you're interested, reach out to us. We can arrange an early pilot. So this is actually moving data at very, very precise level, aided by a catalog. So here's an example of building an AI model using different scenario. Let's say a car making a turn, right, in this very narrow street. And you can see under that stop sign, there's a curbstone, right? Now, if you don't train the model recognizing the curbstone, the car might run over it. It doesn't recognize it, right? It might see it as a plastic or something. But in this case, we can build or enhancing the model by recognizing the curbstone. But to do that, we need to bring out all the images or the clips that have the curbstone, right? And then label them in the video clips or the images, then train and fine tune the model to do that. And while doing that, we can using the global data platform to orchestrate the data, because that image might already be in an archive, right? Or in a cloud object store. We can use this capability to orchestrate the data out of the backend to the GPUs, right, for AI training. And we can do this very, very precisely, provided, right, we do help with you govern the data in the first place. Okay. Another value add, right, in terms of how do you manage the data to help you deploy AI and make the AI more effective. I call this, I need an image with a curbstone on a rainy day, right? So think about the scenario you might have for your AI model and how we can help you, right, achieve that through this capability. Smart move, orchestrate data. The last one I want to leave you with is the most exciting feature around cloud lakehouse. So IBM is actually developing and already GAing the first instance of watsonx, which is our data and AI platform, right? In this platform, you can actually integrate the data together, right? The watsonx.data piece, which I'm showing here on the left, that architecture that bring underlying data together, right? Whether that data sits in an object store or in a database, right? And virtualizing it and caching it into a runtime by a scalable SQL query engine, whether it's Presto or Spark. And this is watsonx.data. And from day one, this architecture for watsonx.data is fully and seamlessly integrated with global data platform and also using the hybrid cloud platform. There's no other option, as a matter of fact. If you want to deploy this, you will be deploying this in OpenShift. And Fusion software is already entitled into the watsonx software, right? So what does it actually look like? So I have a couple of screenshots here for a demo. If we do a workshop with you, I'll be happy to actually run this live. So look at this this piece right here, where you have a engine, right, that access the different data under the hood. And then these data actually sits in different bucket, right? So they actually real bucket from an S3 object storage in cloud, on-premise, right, in a data lake. And some of them can even be a database, right? Now, once you connect them, then on the back end, you can build different schemas. You can build different tables, right? Even the data sits in a object storage as a CSV file or different file optimized file format like Parquet or Orc, right? I can now query them live. And then on top of that, I can build an AI program or analytics program that can plot out the temperature. So in this case, the data set is a National Weather Center data set from 12,000 stations worldwide, collecting data every day from the last 100 years, right? So think about the data points we have, yet now we can make all that data accessible through the global data platform, and then through the Presto engine in watsonx.data, right? Feed that into an AI program to plot out the temperature, right? Boston, very cold in the winter, mildly hot in the summer. I live, by the way, these are the different cities I was showing when I was at the MIT lab presentation, right? I live in St. Louis. You can see it's one of the coldest and also pretty hot in the summer, right? So you cannot appreciate the data to insight, right? Through the architecture, through the IA stack for AI. So to sort of put all this in perspective, think about the dimensions we're working with, right? I talked about, performance, how to drive and feed the GPUs, which are very expensive, right? Yet maintain the cost because you're going to have so much data. A lot of these data will likely help you with a big bill if you don't control the egress costs, right? So the product here is a global data platform named IBM Storage Scale, right? Short for Scale. Some of you might know this as GPFS, as a name a lot of people still fondly remember and use. And so that's a blue layer, data for the highway for data. Fusion is the software that delivers the hybrid cloud platform together with OpenShift, along with the appliance, right, for HCI. Defender that Tao just presented is part of this infrastructure, software defined, right, and leveraging Defender. Actually have a Defender ready storage ready nodes that can allow you to deploy this. So an example here would be, let's say I can deploy a model, right? The model actually have data sits on FlashSystem, right, and being protected using Defender. And then the data actually will be served using Scale, right, through the global data platform to the Fusion HCI system, right, for inferencing and training and so on. And on the left, we also have a very exciting merge of the Red Hat Ceph into IBM. So now if you think about Ceph, it can actually help with all three, right? Ceph can be the backend for Fusion, can be the backend for Scale. It's a very cost-efficient, software-defined storage software, which also have an open source upstream. So this can all bring everything together, right, into a coherent platform. And it, by the way, it's not just for AI. I did talk about AI, right? It can also be for your high-performance computing, for your analytics, right, for your database, right? Whether it's DB2 Oracle, lots of the world's largest database runs on top of this architecture and platform. But what's really new here is agility on top, right? How we can now bring this quickly and deploy them for your production in a matter of days versus weeks. Time to results, time to science, right? Time to innovation, while keep a lid on cost.
Cool. Frank, we're almost out of time, but basically,
yeah, I think that's
nice
it.
And everything, but
yeah.
If a customer's got a business need and they've got the resources to develop either their model and everything, how much, what much time would they take to spin up something like that in their data center so that they could start working? I mean, does it take months? What's the how long does it take, right?
I think if you budget for months, you should surprise yourself by working with IBM and NOVIPRO and reduce that down to weeks. And then even better, to be able to deliver and showcase the value, right, in a matter of days versus waiting, right? And let us help you shorten that life cycle, because ChatGPT version 5 is coming, right? So your customer is going to continue to get intrigued and excited about doing things with AI, having an architecture that's ready, but more importantly, have proven technology and a partner that's trustworthy to work with you is probably most important. Because imagine now, I give this presentation 10 years from now, right? The technology might change, but the color remains, the architecture remains, right? So you want that consistency, you want that future proof. And then the last thing I would leave you with is everything I'm showing you here is proven with other use case before. We didn't invent something here for AI, right? Everything we've done here, including building the world's largest supercomputer for AI, which we accomplished 3 years ago with the world's largest GPU cluster for Oak Ridge, right? Everything here I show you came from that long history of learning, improving, right? And then this Gen AI is just another episode, right? So thank you for your time. Any more questions?
Well, I don't have any question right now in the question and answer, but basically, if you can advance one more chart.
Yeah, sure.
Everybody will receive a copy of the presentation, and if you'd like, just download the IT trends. This is analysis that NOVIPRO, Léger Group basically do for the last 7 years, where they actually do surveys of 500 CIOs and leaders in the technologies to see where the IT is going. So you'll all get a link to the presentation, and I encourage you to actually get this document. It's free, and you'll see some interesting data in there. And if you want to go to the last slide, Frank.
Mm-hmm.
In there, you have my contacts. So should you have any need in information, either from what Tao discussed, from what Frank discussed, any other matter that you'd be interested, just contact me and I'll get you in touch. If I don't have the information, I'll get you in touch with the people that have the information. And on this, if there is no question, I will thank all attendees. I will thank Tao and Frank. And on this, I will wish you a good afternoon.